There are three acid-base definitions for this chapter, or three in general. The Arrhenius acid-base definition says that an acid increases the concentration of H plus, and a base increases the concentration of OH minus. Arrhenius acids are those that have H plus to give away. So Arrhenius bases are those that have OH minus, like metal hydroxides. Okay? Those are Arrhenius acids and Arrhenius bases. They do not encompass all the acids and bases. So because of that, somebody came up with a Bronzolari acid-base definition. And here, an acid is a proton donor. Meaning that an acid will give away an H plus, the same as in the first definition. Okay, so acids here would be like HCl. But a base is a proton acceptor. Meaning it does not have to have OH minus this time. Okay, of course, OH minus, does it accept a proton? Yes, it does. It accepts a proton to become H2O. But bases under this definition could be nitrogen-containing bases or anything that has a lone pair. So things that have a lone pair or negatively charged are bases in general. Yes or no? What did I just say? Lone pair or negatively charged are bases. Okay, in general, not all the time, yes? Most nitrogen-containing compounds, you can say they are basic. Okay, most, not all. And in the Lewis acid-base definition, and this is the one that is the broadest of all definitions, meaning this encompasses all acids and bases. Does this encompass all acids and bases? No. Okay? This is only those that increase the concentration of H plus, concentration of OH minus. A Lewis acid is an electron pair. Lewis acid. Tell me. For those of you that are not going to remember this, is this an acid or a base?
Acid.
Acid. Acid in general positively charged or need electrons, yes? So, this is an acid. Does it need electrons or does it want to give away electrons?
Give away.
It does not have anything to give away.
Oh.
Okay? It gave it away before, but not now. Now it doesn't have it. So it does not want to give it away. What does it want to accept? Electrons, yes? So an acid, under this Lewis definition, is an electron pair acceptor. What do you think a base is going to be? Electron pair donor. What that means is things that have electrons are going to be bases, and things that need electrons or accept electrons are going to be acids. Conjugate acid-base pair. Do you think you're going to have one of those definitions on the test? Of course you are.
Hopefully not this one.
I'm going to give you easy examples. Oh, I did not finish with this. Acids under the Lewis acid-base definition are things like incomplete octets, like AlCl3. Aluminum here has how many bonds? Does it have 8 electrons? Aluminum does not have 8 electrons. BF3, another Lewis acid. Incomplete octet, incomplete octet. So, compounds that are incomplete, that have incomplete octets are Lewis acids in general. Other ones are transition metals, like this, for example. Where is that located at in the periodic table? In the transition metal, so that is expected to be a Lewis acid. And it is a Lewis acid. And what is the definition of a Lewis acid again? Electron pair what? Acceptor. So you expect this thing that does not have electron pairs, you expect an electron pair to go to it. Yes or no?
Yeah.
Okay. And what else? you have things like this. Okay, things that are positively charged are expected to be Lewis acids because they will accept electrons because they're missing electrons. So for Lewis acid, positively charged species, yes, transition metals, and incomplete octets.
The FeCl3 is the transition metal?
Yes, Fe is a transition metal. Cobalt is a transition metal.
And Bronsted was lone favorite.
Huh?
And I think it was Bronsted.
Yeah, Bronsted is like almost the same as in the first
Okay.
Arrhenius.
Transition metal, positively charged species, and what else?
Incomplete octet.
Incomplete octets. All right, conjugate acid-base pair. Let's say that this is an equilibrium, okay? Let's say it's an equilibrium, it's not, maybe under very high concentrations. This is the conjugate acid-base pair. We have to determine which one is the acid, which one is a base, which one is a conjugate acid, which one is a conjugate base. In an equation like this, the acid and the base are on the reactant side. Acid and base on the reactant side. Conjugate acid and base on the product side. Yes or no?
Yes.
Okay. So the acid is going to be the one that gives away the H+. Yes? This compound neutral or charged? This is neutral. If it gives away an H+, the rest of it has to be a minus. Yes or no?
Yep.
So, how do you know whether this is the acid or the base? Well, you look in the other side, and in this case it's easy, yes? You look in the other side. Here's HCl. You look for Cl again, and Cl no longer has the H next to it. That means that it gave away, that gave away the H+ and became this. So this is the acid because it donated the H+, yes? Now the thing, after the acid gives away the H+, it becomes something called conjugate. And you either have a choice of writing conjugate acid or conjugate base. What do you think that would be?
Base.
That has to be a conjugate base. First of all, it's negatively charged. And second of all, it is what comes from the acid. So the acid gives the conjugate base. And the base produces what? The conjugate acid on the other side, yes? So here is the base. How do you know this is the base? Because it gained a proton, yes? It gained a proton. You see here it had 2 hydrogens and here it has 3 with a positive charge. It gained H+. So this is the base and this is the conjugate what? Conjugate acid because it's positively charged and because it came from the base. Even if it's negatively charged, it might be the acid. Yes or no?
So the H3O is the conjugate base as well?
Hmm?
The H3O is the
Oh no, conjugate acid.
Oh,
Did I say conjugate base? No, I said conjugate acid. I said conjugate acid, but someone told me right base. So I add water to that. Maybe we shouldn't do this one. Let's do another one, okay? I don't want to get into this one yet. Let's do another. What? No, you can do it, but let's do another one that it's not confusing like this.
I thought you said the base was the electron pair donor.
Let's do this. This is aqueous and aqueous. This here is called carbonic acid. Okay? So, this is carbonic acid. You never guess what this is going to act like. The acid or the base?
The acid.
The acid.
So
So,
give away a hydrogen.
it's going to give away an H+, yes? Once it gives away the H+, it's going to become 1H still left, CO3 with a minus charge, yes? Now the H+ was taken by the water, so it is going to become
H3O.
H3O plus. This thing here, H2CO3 is what?
Acid.
This is the acid. And the acid gives away an H plus to become what? The conjugate base. This is the base. How do you know this is the base?
Because it's of the acid.
Because it accepted a proton to become what? The conjugate acid. So the acid gives a conjugate base, produces a conjugate base, and this is here the base.
What's the name of that other, the sodium conjugate base?
Huh?
What's the name of that? Sodium conjugate base?
The name of this? I wouldn't know. Do I look like I know it all? That's called bicarbonate.
Oh, which one?
Yeah.
Wait, I'm sorry, I thought you said that the acid is the electron pair acceptor. Which definition are you using on there?
Yeah, me too.
The definition I'm using is Bronsted-Lowry.
This one?
Yeah, the definition we're using now is Bronsted-Lowry.
Yeah.
It's still the same though, but it's difficult to see it.
What if you had something like sodium bicarbonate reacting with water?
What?
What if you had something like sodium bicarbonate reacting with water? Would it be an
Yeah,
acid?
that's what this is. Okay.
So it doesn't matter what's next to the bicarbonate?
It doesn't matter what?
What's next to the bicarbonate? So if it was like sodium bicarbonate?
The sodium is spectator ion. Sodium does nothing. It's a group 1 metal. Yes. So it will dissociate, and this is what's gonna do is, I want you to use this as a base now. This is bicarbonate. Use it as a base with this and provide the product. Why are you looking at me? You're supposed to be writing on your paper. This is bicarbonate. It's gonna act like a what here?
Base.
Let's say this is gonna act like the base. And for purposes of completion, why don't we make it act like an acid in another one? And provide the products. So, here this is acting like the base, yes? What is it going to do? It is going to accept H plus, yes? If it accepts an H plus, the plus will cancel with a minus. So this is going to become H2CO3, yes? So this is the base, and this is called the conjugate what? Conjugate acid. This acted like a what? Like an acid. It gave away the H plus to become OH minus. Yes or no? Here this acted like an acid, so it did what? It gave away the H plus to become CO3. CO3 2 minus.
Carbonate.
It had a minus from before, and when it gets rid of this H plus, it produces another minus. So CH3 2 minus. And who accepted that H plus? The base, which happens to be H2O to produce H3O plus.
Professor.
So this is called the conjugate, what? The conjugate base. And this is called the conjugate acid.
So if you
Yes.
You will let us know which one, in which case it's gonna behave like a base or acid.
I may not, it depends. You'll have to know
And how I
some.
know in that case which is the same.
No, in this case, you don't know. That's not the case in all the cases.
So if you put this ion in solution, how do you know whether it's gonna behave as an acid or a base?
And what?
If you put this ion in solution, how do you know if it's gonna be an acid or a base?
That's based on the pKa, that's not yet, okay? When the time comes, you calculate the pH of everything, and then you'll know what it is. So, take-home message here is, some chemicals can either act like a base or like an acid, yes? Bicarbonate here did that, yes?
Water.
Bicarbonate here acted like a base, and here it acted like an acid, and water did the same, yes? Water acted like an acid here and a base there. When something acts like an acid and a base at different points, this is called amphoteric. So, amphoteric that's the word. Amphoteric can act like an acid or a base.
At different points, or?
How do you know it's
How would you know when, like, acid or base is
That's what he asked 5 minutes ago.
Oh, no, I was not.
You were not listening. I know you weren't. You never are.
Okay. That's my question.
Huh?
Answer.
I'm not gonna answer it. Watch the video.
Are we gonna have to come up with the products on the test?
Yeah. Guys, on the test, she asked this question, then he asked the same question, then he asked the same question, then she asked the same question. Next person that asks that question, I'm gonna stab you when you leave today. Okay? Is there a way for you to know whether this is going to behave like a base or an acid under these conditions? You don't, yes? Yes? But there is a way to know if the reaction is going to go in that direction or is gonna go in this direction, which I'm going to explain later. We're gonna calculate the pH of all of these things, okay? So, at first you don't know, but you do have a list of strong acids, yes? Do you? Do you have a list of strong acids? What are they?
HCl, HF,
Hydroiodic, hydrofluoric, hydrobromic.
So, let's make that official, yes? HCl, HBr, HI, what else? HClO4, HClO3,
Sulfuric acid.
HNO3, H2SO4. Is that 7 of them? Now, does that mean that these are the only strong acids known to man? No. This is the list that most people give in a class like ours, okay? Are there strong acids in this? Yes, there are. This doesn't mean these are the only strong acids, but in this class, if I give you anything other than those, guess what they are going to be? Weak acids, right?
Yep.
So, of the weak acids, you have to know that this is, for example, a weak acid. This is called acetic acid.
Mhm.
This is a weak acid. Another weak acid is HF. Now there are more. I'm only showing you those. So if
what about phosphoric acid? Is it strong or weak?
it's weak, it's not in the strong acid list.
Is that HF or HI?
What?
Is that HF or HI?
HF. Which one, man? That one on the top or this
The
one?
one on top.
HR.
HI? Okay. Yes or no? So, write an equation for this. So obviously, that is an acid or a base? An acid. So if it is an acid, it's going to act like the acid. Now, if this were amphoteric, it could either act as one or the other, and then you couldn't choose, yes? But you can choose here. This is an acid. It's going to act like an acid. So write the equilibrium for that.
Does it react with anything?
Yeah, water.
Always? Okay.
And not always water, but water now. If I don't tell you what it is, it's in water.
Okay.
Okay? So I'm going to write this aqueous plus H2O. H2O liquid. Did I write H2O aqueous before?
Yeah.
You go change that, okay? I'm having a bad day apparently. Okay? So this is going to act like an acid. What is it going to do?
Give away the hydrogen.
Give away the H plus. Which H plus is it going to give away?
All of
Which
it.
H is it? This one?
No.
How do you know?
The Lewis structures.
The Lewis structure.
Yeah, you can see it. Figure it out.
I told you? I don't remember saying that. Last class I said it? Yeah, you're right, I do remember. The hydrogen that is lost is the one next to, the hydrogen lost is the one next to the oxygen. The difference in electronegativity here is 0.4, meaning this bond is not very polarized, okay? But this bond is polarized, this is more delta positive than this one. That's why this is the bond that breaks. I'm going to explain more of that later, okay? Just sit tight. So this is going to give this H plus because it's next to the oxygen and it's going to look like this. COO minus. Yes?
Yep.
Somebody must have accepted that H plus, and in this case, it was water. It doesn't have to be water, it could be something else. It could be a base, like sodium hydroxide, okay? But in this case, we're doing it with water because we're doing it easy, yes? H3O plus. This is called the what acid? And the acid gives conjugate base. And of course, is this acidic or basic? Basic. If it's going to be anything, it has to be basic, yes? If it's going to be anything, and it is basic, but you don't know that yet, you just imagine that because it says conjugate base, and it's okay. That's what I want. And this is conjugate acid. Very good. Yes or no? So here we have
Strong acid.
we have this thing here, and we have this other thing here. Do we know what this is? Is this an acid or
Oh,
a
you didn't
base?
put the two.
It looks like a negatively charged thing, yes? And this looks like a negatively charged thing too. But this is on the strong base list, is it not?
Yeah.
This is from a metal hydroxide. These are the net ionic equations, yes? I didn't put a sodium here or potassium. So what this is going to act like the base. Now Now, the reason why that acts like a base,
In that case, is HSO4 or H2?
HSO4 minus. Yes. Not this. It is this after it gives away an H plus, because this is an acid. And by the way, this is also amphoteric. Okay? So, if this is the base, I just want you to realize that here, this is negatively charged, yes?
Yeah.
And this is negatively charged. So which one do you choose as the base? You choose as the base whichever one is stronger.
Okay.
Okay? Now, how do you know which one is stronger? I'm not teaching you that yet. I will later. This is stronger. I'm telling you. Here it is. Base, because it is stronger than that. And what is that going to give you?
The base is gonna give.
SO4 with a 2 minus, yes? Plus H2O. This is liquid. This is aqueous. This is the acid. And what is this? The conjugate base. And this is the conjugate acid. Write the equilibrium for HF in water. HF in water. HF HF is what?
Acid.
Weak acid.
HF is a weak acid. How do you know that HF is a weak acid?
It's not a strong acid base.
Because it's not in the strong acid list, but you know that HF, because I wrote it on the board, is a weak acid. Okay? HF is a weak acid because everybody knows that. Plus H2O gives you F minus, yes? The HF gave away the H plus to become F minus and H3O plus. Yes or no? This is an equilibrium reaction, yes? Equilibrium. This means that this reaction is going forward, but it's also going reverse.
So even if
All of it is not going forward, yes?
HF is a weak acid, it's still, and water is amphoteric. The weak acid is not trumped by the amphoteric, like.
Now,
Yeah.
amphoteric means that the substance can act
Yeah,
like an acid or a base, depending on the situation.
like here it's a weak acid that it's reacting with. So the amphoteric wouldn't be stronger than the weak acid to play the role as the acid.
No, the amphoteric can do either thing, depending on the other thing.
Alright,
Okay, so you don't worry ever about amphoteric, because amphoteric can do whatever. So, but this is an acid.
so since you see an acid, the other one's just a base.
That's right, the other one has to be a base. So, here's the acid, because you know this is the acid. This one will be the base. And this will be the conjugate,
Acid.
F minus, the conjugate
Base.
base.
Base? Ah, is that?
Yeah. And this is the conjugate acid. How's that, guys? I don't know about you, but I'm tired of doing this. From the strong bases are those that are metal hydroxides are the ones that I can give you. Okay? Metal hydroxides like group 1, yes, sodium hydroxide, potassium hydroxide, calcium hydroxide, that's not group 1, yes?
And then there's like calcium, strontium, and barium.
Yes. So most of the hydroxides that I can give you, you just take them as strong bases. Yes? Now, the ones that are not strong bases are like NH3, nitrogen containing.
What was the first one?
Those are weak or?
This is M, this means metal. Yeah, this is a weak base. Nitrogen containing is a weak base. So let's do an equilibrium for this one. Nitrogen containing, whatever that happens to be. NH3 plus H2O give you what? Of course, water is amphoteric, yes?
Mhm.
So sometimes it acts like an acid and sometimes it acts like a base. It doesn't interfere with anything. It just does whatever the other thing wants to do.
So it's gonna become a hydroxide and
Yeah.
ammonium, right?
Okay? Yes.
Cool.
So the NH3 is going to be the base and is going to pick up a hydrogen from the water to become NH4. This is called ammonium. Yes? Plus OH minus. This is the base. This is the acid. This is the conjugate acid. And this is the conjugate base. How's that, guys?
Good.
Huh? Okay, simple enough, yes? Let's do some conjugate bases of some stuff. So what is a conjugate base? Of the following acids, yes? I'm gonna give you a second. I want the conjugate base of those. I don't want you to write an equation. You could write an equation, but I don't want you to write an equation. I want you to give me the conjugate base only of those. What's the conjugate base of HClO4?
ClO4 minus.
ClO4 minus. You take away an H plus. What's the conjugate base of H2S? HS minus. Very good. What's the conjugate base of PH4 plus? PH3. Okay, you lose an H plus. It's gone, so now it's neutral. And what is the conjugate base of HCO3 minus? CO3 2 minus. Very good. There are questions on the test like that. I consider that 3 points. You guys have done this in PLTL already?
No.
Why not?
You gotta study for that exam.
What happened?
You gotta study for that exam.
You gotta study for that exam. I'm gonna be almost done with this chapter by Tuesday of next week. So you're gonna be a chapter behind.
Is this your last chapter for the test information?
No, this is not on the test, yes? This class is not on the test.
Okay. Thank God.
The test is only kinetics and equilibrium, yes? Not this. What we are doing today on acids and bases is not on the test. Well, what I said at the beginning, yes, it is, right? The and a catalyst.
Cyanide. I haven't seen that before. Is cyanide deadly?
Is cyanide deadly?
Yeah.
Yes. To most people, it is.
Most people. There's like a certain breed of people that's not deadly.
Kills everybody. Huh? The deadliest? I don't know, the deadliest is a shark, man.
Did you say the sharks are not actually that harmful?
The what?
Did you say the sharks are actually attack them?
I did say that. And it's true. But people be swimming in the beach, and the sharks are disoriented, so they take a bite of people. They don't eat people.
Yeah, we're not to their taste.
Believe me, if you were to go to the Everglades and you get near a crocodile, what do you think they're going to do to you?
Eat you.
They eat you.
Oh,
They
yeah.
do eat you. Crocodiles don't take a bite and let you go. They eat you.
They don't care what.
But you don't see people talking about crocodiles biting other people, right? You know why? Because people don't get close to crocodiles. That's why.
They spin them too.
What?
They spin you in the water, and then once you
The
die,
death
they
roll,
spin
right?
you in the log, and then they come back and they take little bits of you.
No, yeah, man, they mess you up bad. That's why I eat them crocodile bites. Alligator bites, yes?
The tail's delicious.
No, they don't taste delicious,
The
man.
tail is all meat. It's pure meat.
Yeah, but have you tasted that meat before?
It's like masita de puerco.
Nah, hell no. It doesn't taste like chicken, I'm sorry. You do not know what chicken tastes like. It tastes like chicken. I ate them alligator bites and they were, I bit on them and they released this juice. And it was salty and fishy. And then I chewed again and oh man, it's like a gummy bear of fish. Never again. So I stopped eating it, I just swallowed the whole thing. Alright, Cn minus. What's the conjugate acid of that? HCN, outstanding. What is the conjugate acid of this, Ms. Rodriguez? What's the conjugate acid of this? I'm talking to you. What is it? None of her friends say it, I'm gonna smack somebody. Somebody said it to you anyway.
No.
Liar. I don't believe you. You still got it wrong. Alright, so you add an H plus, yes? H plus canceled with one of these minuses, you have one minus left behind. Add an H plus to this, that will be H3O plus. Add an H plus to this, it will cancel with this, so it's gonna be neutral. Yes? And I add an H plus to this, now this is gonna have a plus, yes or no? Very good. Anyway, if you don't want to get bitten by a shark, don't go to the beach. No, you can get in the water, but not at the beach. If you get in the water in 20, 30 feet of water, there's no bite. Shark bites at that depth, okay? Huh? Yeah, because they're confused, you know? They're confused.
Those sandbars, they come up like from the deep.
Dude, like, you hunt like 30 feet of water.
It's crazy.
In bullshit?
Okay. Alright. Anyways, news, yes? Shark biting people. Everybody wants to hear about that news, yes? You ever heard of alcohol killing people? Kill 30 million people, yes?
Yeah.
Nobody talks about that. Alcohol is deadlier than a shark.
Hell yeah.
Huh? Mosquitoes too. And bees. And red ants.
Well, bees not real.
You know how many people dogs kill a year? Dogs? Like about 30 people. Dogs. And most of them deserve it. Yes? Going into somebody's backyard? I mean, so a dog is deadlier than a shark. And sharks and dogs don't eat people either, yes? Alright guys. What do you want to do now?
Chemistry.
Go home, absolutely not. Let's do this. Why don't you make this an acid and that a base?
Wow, someone's excited.
It is exciting. I can barely hold my emotion.
I think you're holding it pretty well.
Ms. Rodriguez, next class I want you to sit on this chair.
Okay.
So she's gonna be teaching.
She's gonna be teaching.
I want my money. I want
I
my money
spit like a
back.
llama, so. What are you taking, man? No drugs in class.
No, it's not drugs. You don't take it from my foot.
That is drugs, isn't it?
What
It's
is it,
drugs.
ibuprofen or something?
It's like a Vicodin.
It's not recreational drugs, but it's drugs nonetheless.
Oxycodone?
What is it?
Calcium and other shit from your foot.
Oh, calcium.
Yeah.
Give me some, I wanna be myself.
Why don't
That
you
must
just
be
drink
good.
orange juice, man? Okay, guys. So if this acts like the acid, what does it become on this side?
H2O. I'm sorry. I'm sorry.
Okay. All right. You want this to be the base then?
Yeah. I mean,
Yeah.
make it
The first one is always the acid, you said?
No, it's all the base.
It's always a base?
It doesn't matter.
It doesn't matter, right? But some of you... Okay, let's make that the base then. It doesn't matter. Don't change it on your notes. What is it going to give you on the other side? If this is the base, it is going to get a proton,
Hydroxy.
yes? It's going to become H3O plus. And that gave away, this is the acid, it gave away the H plus and it became OH minus. Yes or no? So on this side, you will have H3O plus and OH minus. It doesn't matter if you write this first or second. Yes, it doesn't matter. Let's write an equilibrium constant for that. What's the equilibrium constant for that?
Products divided by reactants.
Products divided by reactants. Okay. This is aqueous, yes? So it's the concentration of H3O times the concentration of OH minus divided by the concentration of H2O, yes? No?
Those
It's
are
not
liquids.
divided by a concentration of H2O?
Those are liquids.
No, because this is liquid and liquid. Okay?
So you just multiply them.
So, no, you don't multiply. I mean, they're not included in the equilibrium
No, but
expression.
the other ones. Yeah.
So, that's it. That is the equilibrium constant for this. And this has a special name. This is called autoionization of water. Do you see it? Water with another water ionizes. Yes? This is what happens in real life. So, because this is the autoionization of water, this equilibrium constant is special and it is called Kw. And Kw is equal to H3O. H3O plus times the concentration of OH minus, yes? is Kw a known thing or no?
Yes.
Is Kw a constant?
Yeah.
And it's known, yes? People know what the value of this equilibrium constant is. And the value of this equilibrium constant is 1.0 times 10 to the minus 14.
So that's the value of K.
Kw, yeah. How's that, guys?
Cool.
So if I were to give you the concentration of H plus, can you find the concentration of OH minus using that equation? Yes, if I give you OH minus, you can find the concentration of H plus using that equation. So let's do that. That's what you wanted to do. So let's say calculate concentration of H plus if the concentration of OH minus is equal to 1.0 times 10 to the minus 9 molarity. And of course, how simple of a problem is that? I mean, in the difficulty scale, 1 through 5, 5 being the most difficult, this is what level?
0.5.
Like -3 or 4, yes? So, this is how it is. Concentration of H plus times concentration of OH minus is 1.0 times 10 to the minus 14. You learned this in biology, didn't you? No, you never took biology. Concentration of H plus is 1.0. I am solving for H plus, yes, divided by OH minus. 1.0 times 10 to the minus 14 divided by 1.0 times 10 to the minus 9. What does that give you? 1.0 times 10 to the negative 5. Does this have units?
Molarity.
The units are molarity. How do you know the units are molarity?
Because you're talking about concentration.
Because it is concentration of H plus, yes? But you notice that does this equilibrium constant have units?
No.
No. And does this have units, OH minus?
Yeah.
It does. And it's on the bottom, yes? So this arbitrarily, not because the units cancel out or anything, we're saying that this is molarity because it's concentration, and that's it. Yes or no? So let's say we have this. Do you know what a strong electrolyte is?
Yes.
Strong electrolyte completely ionizes, yes? If it is a strong acid or a strong base, it is a strong electrolyte. They completely dissociate. So let's say, calculate, let's make it a little bit more difficult, yes? You want it difficult or you want it easy?
Really difficult.
Difficult?
There is no difficult question.
So, calculate the concentration of H plus. In a 0.015 molarity sodium hydroxide solution. That still has difficulty level of -3.
I got it.
Remember, there is no challenging problems, yes? There is only you not knowing. When you don't know, that's called a challenge. So you think your child is gonna be a chemist? Hmm?
Huh?
You think your child is gonna be a chemist?
I don't know.
Whatever, girl.
Maybe
Because you're supposed to be feeding him or her. It's a him or her?
her.
It's a her?
Yeah.
You're feeding her a lot of chemistry, yes? Okay, so what do we have here, my friends? Sodium hydroxide, strong acid or strong base?
Strong base.
Strong base. What that means is this is completely
Dissociated.
ionized, okay? So that concentration, when it breaks like the Van Hoff factor thing, yes? It's going to break into 0.15 molarity of sodium plus and 0.15 molarity of OH minus.
Mm-hmm.
Does this make sense to you, yes or no?
Yes.
It completely dissociates into the components, yes? So that amount of the first component and that amount of the second one. The second one is what we're interested in, yes? So the concentration of OH minus is 0.015 molarity. What's the concentration of H plus? Hello? 1.0 times 10 to the minus 14 divided by 0.015. What does that give you?
6.67 times 10 to the minus
6.67? So let's say 6.7 times 10 to the minus what?
13.
Units, moles? How's that, guys? Huh? How do you guys feel about that?
A harder one.
Like I said, they're all easy, yes? I give you a harder one, you can't do it.
So 1.0 times 10 to the negative 14 is always for hydrogen, H plus. That's the value for H plus.
What is it?
I'm just not sure how like the 1.0 times 10 to the negative 14 is like involved.
No man, this is the equilibrium constant. This is called KW.
Okay.
This 1.0 times 10 to the minus 14 is KW,
Okay.
which is equal to these two. The value of H plus is not that number.
Okay.
The value of H plus is that number divided by however much OH minus we have. You want another one, yes? Let's do another. Calculate the concentration of H plus in a 0.0055 molarity. You don't say a word, you don't ask anything, you just do it. You hear? You don't ask a question. So if you do it wrong, you learn from your mistakes, yes?
I don't remember if calcium is an exception to the dissociating on the. No, it's not an exception.
How much is it?
9.09 times 10 to the
Okay, well, I need concentration of H plus times concentration of OH minus, 1.0 times 10 to the minus 14. That amount of calcium hydroxide. So, calcium hydroxide is a strong base. So the concentration of OH minus is going to be equal to what? Huh? 0.055, but there are two OHs there. You gotta multiply this by 2,
Yes, that's what I thought.
okay? Just like the Van Hoff factor, yes or no?
Mm-hmm.
You guys should be ready for this. So OH minus is equal to what? You multiply that, I can't do that math.
0.011.
Really? 0.11?
Yeah.
What?
Molar.
Molarity. What is it that I'm looking for?
H plus.
I'm looking for H plus. So 1.0 times 10 to the minus 14 divided by 0.011, what's that equal to?
9.1 times 10 to the negative 13.
9.1?
Times 10 to the negative 13.
Negative 13 molarity. You got it wrong? That's cool, man. Learn from your mistakes. Don't get it wrong again. It happens. I expected most of you guys to get that wrong. This is why I did the problem.
But if it doesn't dissociate completely, do you need to make an ice chart then?
Yes, you do. Okay, so let's talk about pH. Yes?
Sure.
You like pH? pH is the negative log, and this here says negative log, okay? For those of you that can't read my handwriting, that says negative log. Negative log of the concentration of H plus is called pH. Okay, POH is the negative log of the concentration of OH minus. Do you get the point of what P means? P means negative log of whatever follows it. Yes?
The absolute value of the exponent basically.
What do you mean the absolute value?
So like if it's times 10 to the negative 7, it'd be
Not
7.
absolute. Yes, if it's times 10 to the negative 7 because the minus cancels with this. So, what about,
pH plus pOH should be always 14.
yes, PKW. What's PKW? Negative log of KW. What's PG?
Muy everyone can see.
My initials. Oh. You got that one wrong on the test. All right, so anything that has a P in the front means negative log. Okay, very good. So let's not do it like this, let's do it like this. You agree?
Yeah.
This KW is a number, yes, 1.0 times 10 to the minus 14. I'm going to find the negative log here. If I find the negative log there, negative log of H plus, this is multiplying, so plus the negative log of OH minus. Is equal to the negative log of KW. Do you agree with this math? So, negative log of H plus is called pH. Negative log of OH minus is called POH. And negative log of KW is called PKW. The negative log of 1.0 times 10 to the minus 14, 1.0 times 10 to the minus 14, if this number is 1, it is just that number, okay? Not negative 14, well, times a negative is, so PKW is 14. Yes, so this is pH plus POH is equal to 14. The pH scale goes from 0 to 14. Yes? Now, do you have to know this whole thing? No. That's what you have to know right here. Look. pH plus POH is equal to 14.
Is that negative log 1.0 times 10 to the negative 14?
Yes, it is. Does the one look like a C?
I don't know what it looks like.
All right. calculate the pH of a 0.0025 molarity sodium hydroxide solution. You can find whatever you want. You can do pH. And then you're gonna change it to pH though.
You get 2.60.
So what is it that I'm looking for here?
pH.
pH. And pH is equal to the negative log of H plus. You agree? Now, what I have, is it an acid? No. Is this an acid? No, it's not an acid. It is a base. Is it a strong base?
Yes.
It is a strong base, so all of this concentration will ionize into OH minus. Yes or no?
Yeah.
So the concentration of OH minus, which is what I can get from that strong base, is equal to this number.
Yeah.
We have already done this a few times, yes?
Yep.
Now, I got two choices. I either find the POH here, yes?
Mm-hmm.
Because I have the concentration of OH minus, I either find the POH from here, or change this to the concentration of H plus, and then find the pH. What do you want to do?
Just find it from there. It's a lot simpler.
Both? Okay, let's do both, since you asked me so vigorously. Okay, so let's say
Do
OH
negative
minus,
log of-
let's change that to the concentration of H plus, yes? 1.0 times 10 to the minus 14 divided by the concentration of OH minus. We have already done this a few times. So I am giving you here less details. How much is this? How much? 4 times 10? 4 point what? 4.0? Yes. Times 10 to the minus 12? Molarity. So now I have the concentration of H plus. I can find the pH. It is the negative log of H plus. 4.8 times 10 to the minus 12. How much is that?
Sure, it should be 12 for that number.
No, not 12 because this is 4.0, not 1.0. It's 1.0, yes, it is 12. How much is it you said?
11.
11? 11 flat?
Whoa, you don't have
Wait.
any figs. It's 11.4, but you don't have that many figs.
Now, the log sig figs are different from the regular sig figs, okay? Log sig figs, you have to keep decimal places. So 11.4 you said?
How many figs? How do you know how many figs?
I don't know, that's in the math class. You gotta take math for that.
Okay.
11.4, yes? If you have one sig fig here, I think you have to have one decimal place, yes? Is it? According to the log function thing, I don't know. So 11.4, yes? Now, we can do it another way, so I'm going to say or. You can say, okay, POH is negative log of OH minus, yes? And
Yeah.
I'm going to say POH is equal to the negative log of 0.0025. What's that equal to?
2.60.
Who?
2.60.
2.6.
2.68?
60.
2.6. So now I have the POH, pH pH does not have units, okay? The units are pH.
So I'd have to divide
So-
that.
pH plus pOH is equal to 14. Yes? So the pH is equal to 14 minus 2.6, what is that equal to? 11.4. 11.4.
Okay, cool.
Which way do you like better?
That way.
I don't really care.
They're the same, okay? Don't get used to something you like. Because life is not gonna give you that you like.
How does pH plus pOH is equal to 14?
It is.
So pH equals 14?
Huh?
So why is pH by itself then not equal?
14 minus 2.6 minus pOH.
Oh, okay.
You gotta solve for pH. 14 minus pOH. How's that, guys? You want another one?
Sure.
Let's do another one. Why not? Class is over. You get here 20 minutes late and your class is over?
2 minutes.
You were 18 minutes late today.
So not true.
That's true. I looked at my watch. I think I'm paying attention to chemistry, okay? All right. So calculate pH of 0.15 molarity HClO4 solution. First thing you gotta ask yourself, is it strong or weak? It is strong. And if it is strong, what does that mean? That this whole thing dissociates, yes? So the concentration of H plus, because that is a strong acid, is 0.15 molarity. You agree?
Yes.
That's the concentration of H plus because that's a strong acid. If it were not a strong acid and if it were a weak acid, would the concentration be this? No, obviously not. Otherwise I wouldn't ask you, is it strong or weak, right? If it is a weak acid, you have to build an ice chart. You guys remember ice charts, yes?
Yep.
You're gonna do tons of it. So that's the concentration of H plus. All I have to do is negative log of H plus. So the pH is the negative log of 0.15. How much is that, Ms. Rodriguez? You don't even have a calculator, do you?
No, I didn't bring my book.
Right. There's always something with you. I mean, you gotta give your parents a medal for handling you all these years. Man.
You get it?
How much is it?
Yeah, but that's the pOH.
Use your phone.
0.85.
How much?
0.82.
Oh, okay. Yeah, but that's the.
0.82? Okay.
So would they like burn your hand off?
Wait a second.
Yes, it would burn your hands. Yes, it would.
Oh, yeah, never mind. Because we're doing it with we're doing it with H plus. That's why you're not considering the pOH, right?
Yeah.
Just going straight to pH. Okay.
Okay, guys? Anything else? You want to do a weak acid one?
Yes, 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 let's go.
P and W is always equal to 14. Did you finish the class?
No, I am not finished with the class, no.
All of it? Number 27 ingredients?
How many minutes do we have left?
10, 11 and a half.
So calculate the pH of a 0.20 molarity
I'm done.
HCN
Really hard.
solution.
You let me know if you want to study. I'd say Monday on that. Please tell me that.
Okay. So this here is the net ionic equation, yes? We can call it net ionic. Did I put, you only have the acid here dissociated into components. I did not include water here. Okay? So this is supposed to look like this. HCN plus H2O liquid gives you H3O plus CN minus, yes? So this water is a liquid, so does it take part of the equilibrium?
No.
No. So I dropped it. That doesn't mean I'm gonna drop it all the time. So because I dropped the water, I didn't put H3O plus here. I just put H plus. Yes or no? So H plus and H3O plus is the same thing. And now I'm going to give you the Ka of this. The Ka of this is 4.9 times 10 to the minus 10. Because it has a Ka, and Ka means the equilibrium constant for the acid, yes? If it were Kb, it would be the equilibrium constant for the base. So this is an acid. I need to find the pH. What's the equation for pH? pH is negative log of H plus. This H plus, when is it? It is at equilibrium, yes? But this does not completely ionize. So in order for you to find the pH of a weak acid solution, you have to build an ice chart. Write it down. In order to find the pH or equilibrium concentrations of a weak acid, build an ice chart. So we're building the ice chart. What's the initial concentration of HCN?
0.20.
0.20. What's the initial concentration of H plus? 0, because it doesn't tell you anything about H plus anywhere. How about the concentration of Cn minus? 0. Enjoy it while you can, because it's not going to stay 0 forever. There is going to be a negative change on the reactant side, negative X. On the product, you're always going to write plus X and plus X. Then this plus this down here, 0.20 minus X. This is X and X. Do you agree with the ice chart? What are we going to do next? I need the concentration of H plus, yes? I need a way to find this X. Do I not?
Yep.
I need a way to find this X. What is that X?
0.20.
How do we find this X? We're going to plug it in into this equation and solve for X, yes?
Yeah.
So Ka is equal to the concentration of H plus times the concentration of Cn minus divided by the concentration of HCN. You agree?
Yep.
I have the Ka, so I have the Ka, or have an equilibrium constant, and I have initial. Initial and equilibrium, you can find what from there? Equilibrium concentration, yes? Hello?
Yep.
So I am just going to plug those numbers in. 4.9 times 10 to the minus 10. What's the concentration of H plus at equilibrium? X. What's the concentration of Cn minus at equilibrium? X. What's the concentration of HCN? 0.20 minus X. Is that going to be a problem for the mathematical impaired?
Probably.
Say yes or no? Yes, it will be a problem for the mathematical impaired. So what we are going to do is, we're going to do something called an approximation. To simplify the math, yes? How big is this equilibrium constant?
Is that the 5% rule?
It is a 5% rule, but how big is this equilibrium constant?
Not very.
Big or
Very
small?
small.
It's small.
Yeah.
So if it is very small, does the reaction go forward by a lot or not by a lot?
Very small. Very
I mean, we spoke about this before. Small equilibrium constant mean the reaction lies to what side?
left side.
The reactant side. What that means is that this change here is very small.
Mhm.
It will not change this number. So since this change is very small, I am going to disregard the change because it will not change this number by a lot. Okay? So the approximation is, when the equilibrium constant is small, anything that has a plus x or a minus x, you will disregard. Plus x or minus x. Can I disregard this x? Hello?
No.
Can I disregard this x? No, I can only disregard whenever there is a plus or minus, I disregard the x. So I'm going to say 0.20 minus x is more or less 0.20. Now, does anyone have a question of what small is small? How much small is?
Yeah.
Yeah. How do you know?
No one knows how small is, yes? I mean, what may be small to some of you is large for others, yes? So,
How do we reference?
that's right. So, I am going to tell you, what do you think small is? 4? 4? 5?
-5 and smaller.
Yeah, let's call it 10 to the minus 4 is small. If this concentration is somewhat large, if this concentration is in the 0.0 something, then it's not very small. So anything that is 10 to the minus 4 or smaller, meaning 10 to the minus 5, yes? 10 to the minus 4 or smaller,
Okay.
meaning 10 to the minus 5. I gotta say that, because some of you don't know. It is equal to 0.10. So this is how the math becomes now. 4.9 times 10 to the minus 10, x squared divided by 0.20. I bet you guys can do that one now. 4.9 times 10 to the minus 10 multiplied by 0.20, x squared, square root there, square root here, x is equal to,
2.21 times 10 to the -5.
no, that's not what I get. I get 9.9 times 10 to the minus 6. What's that? What is this x? Tell me what this x is. X is the concentration of H plus 1 at equilibrium. And it is also the concentration of Cn minus at equilibrium, yes?
Yes.
I don't care about Cn minus because I need to find the pH. So the pH is negative log of H plus. So the pH is negative log of 9.9 times 10 to the minus, what is it? 10 to the minus 6. What's the number? 5 point something.
5.0.
5 point what?
5.0.
5.0? Okay, guys, I'm gonna tell all the professors in the department, everybody's gonna get me an A next week. Okay? Like you did on the first test. Don't
Okay.
disappoint me.
But I mean, this is a lot easier to make mistakes than the last test. There's a lot more intricacies than the last one. Like this content, it's not hard, but it's definitely harder than the last. The other one was no math, nothing.